Today the topic is identification and purification of organic compounds. What are the various techniques for purification? Any idea? Filtration. I can filter tea from the water. First is filtration. What another technique you know? Distillation. Anybody heard about distillation? Sublimation and recrystallization. These are the various purification techniques of organic compound from the impurity. The impurity may be soluble or insoluble in organic compound. And the fifth is chromatography. Okay, these are the various techniques for purification of organic compound. So let's take each of the technique one by one. What is filtration? Suppose I want to separate a mixture of tea and salt. So how do I separate these two mixture? Separate this mixture, one component from another component. First, I'll take some solvent. I'll pick that kind of solvent in which one of the component is soluble in that solvent while the other remains insoluble. I know salt is soluble in water. So I'll take water, I'll mix this mixture into the water. Salt will dissolve in the water, but the tea will remain undissolved, and hence I can filter it using funnel by using the filter paper, obviously filter paper. So this is known as filtrate, and the component on the filter paper is known as residue. So I can separate residue, I can separate that component from the residue by evaporation. Sorry, I can separate the component from the filtrate by evaporation. I'll evaporate water and I'll be left with salt. In the residue, I'll be left with tea. This was the example. This was a general example. Otherwise, the example for this filtration is benzoic acid and naphthalene. Sorry, benzoic acid and anthracene. Benzoic acid is soluble in water. So hence I'll take this mixture and I want to separate benzoic acid and anthracene. I'll take hot water in which benzoic acid is soluble. I'll filter that mixture and I'll be left with insoluble anthracene on the filter paper, and in the solution I'll be having benzoic acid which can be crystallized out by cooling the filtrate, and hence I can separate. This was the example for filtration. The another technique for purification is distillation or sublimation. Let's take sublimation. What is sublimation? A component which goes directly from solid to gaseous phase without passing into the liquid state, and hence it skips its melting point. यानी वो अपने मेल्टिंग पॉइंट पर पहुंचा ही नहीं और उससे पहले ही इवेपोरेट हो गया. ठीक है, मेल्टिंग पॉइंट क्या होता है? जहाँ पर सॉलिड टू लिक्विड होता है. ठीक है, इसलिए यहाँ पर वो इस स्टेप को उसने स्किप किया है, एंड हेंस वी कैन ओनली सेपरेट दोज कंपोनेंट विच कैन बी सब्लाइम्ड. एनी एग्जाम्पल ऑफ एनी सब्लिमेबल कंपाउंड? कैम्फर, naphthalene, So can I separate camphor and naphthalene together? No. Both will tend to sublime together, and hence I can take some mixture. Suppose I am given a mixture camphor plus some anthracene, then I can separate. I know camphor is sublimable, and hence I can sublime camphor and I'll be left with anthracene as solid form. How do I sublime? What is the experimental setup for sublimation? You take a china dish, okay, take a china dish, put that mixture containing A plus B, that means camphor and anthracene, this mixture in the china dish, burner. Do you think you will directly heat? You have to keep a sand bath to provide a uniform heating to the china dish. You'll put a burner, and then you will put a funnel over it with a filter paper on the top of the china dish which is perforated. That means आप एक china dish लोगे, उसके ऊपर फिल्टर पेपर रखो, उसके अंदर कंपाउंड डालोगे, मिक्सचर है, उसके ऊपर फिल्टर पेपर रखोगे, उसके अंदर थोड़े से परफोरेशंस करोगे, यानी थोड़े से होल्स करोगे छोटे छोटे से, ताकि जब वो कंपाउंड उसमें से जो सब्लाइम हो सकता है वो सब्लाइम होगा, वो उसमें से निकलेगा और फनल के ऊपर जाएगा. और यहाँ की वॉल्स क्या है, फनल की वॉल्स, दे आर कूलर देन दी चाइना डिश. सो यहाँ पर क्या होगा, उसका कंडेंसेशन. बट टू अवॉइड कि वो बाहर ना चला जाए, यू विल पुट अ कॉटन प्लग. ओके, दिस इज हाउ द सब्लिमेशन टेक्स प्लेस. सो जो भी कंपाउंड सब्लाइम हो सकता है वो ऊपर यहाँ पर क्रिस्टलाइज आउट हो जाएगा, एंड यू विल बी लेफ्ट विद द रेजिड्यू जो कि दूसरा कंपाउंड होगा, से लाइक एंथ्रेसीन. ओके, what is the another technique? Distillation. What is distillation? Distillation means heating of any compound, say liquid, and then condensing it to get the pure compound. पहले आप क्या करोगे, आपको कोई सपोज करो कोई मिक्सचर दिया हुआ है जिसके अंदर ए और बी कंपाउंड है, ठीक है, मिक्सचर है, वो दोनों सेपरेट हो सकते हैं. यहाँ पर हम किन कंपाउंड्स के बारे में बात कर रहे हैं, जो कि रिएक्ट नहीं करते लेकिन मिक्स हो जाते हैं. मिक्सचर हम इसीलिए बोल रहे हैं, मिक्स होना यानी विदाउट रिएक्टिंग, वो लेकिन मिसिबल है एक दूसरे के साथ, तो उनको सेपरेट करने के लिए सारी टेक्निक्स हम यूज़ कर रहे हैं. सो सपोज ए और बी आपको कंपाउंड दिया हुआ है, ठीक है, आप क्या करोगे, उस ए, सपोज करो ए आपके पास एक लिक्विड है, से एनिलीन, उसके अंदर कोई सॉलिड इम्प्योरिटी है, या हो सकता है कोई लिक्विड इम्प्योरिटी भी हो, ठीक है, कुछ भी हो सकता है. सो यू विल टेक एनिलीन, ठीक है, उसको हीट करना स्टार्ट करोगे. उसके बाद जो वेपर्स होंगे एनिलीन के, आई नो एनिलीन जो है इट कैन वेपराइज, वो वेपर कब बनाएगा, अपने बॉइलिंग पॉइंट पे, ठीक है. आई विल मेक श्योर कि इसके साथ जो भी मेरी इम्प्योरिटी है वो टेंडेंसी उसकी ना हो कि वो वेपराइज हो सकती है, वरना अगर वो भी साथ में वेपराइज हो जाएगी तो मैं डिस्टिलेशन का कोई पर्पस नहीं है. सो आई विल टेक एनिलीन एंड दैट इम्प्योरिटी कि जो सब वेपराइज नहीं हो सकती है. सो यहाँ पर एनिलीन लोगे, साथ में इम्प्योरिटी भी होगी, उसके साथ हीट करोगे, उसके वेपर्स आएंगे और उसको आप कलेक्ट कर लोगे कंडेंस करके. उसका एक्सपेरिमेंटल सेटअप क्या होता है, आई विल जस्ट ड्रॉ. फॉर दिस यू विल टेक अ राउंड बॉटम फ्लास्क and put that mixture into it, ठीक है, you will put a burner, ठीक है. उसके बाद यहाँ पर आप एक थर्मोमीटर डालते हो, ठीक है, साथ में होगी मर्क्यूरी. उसके बाद यहाँ पर एक कंडेंसर कनेक्ट करेंगे, ठीक है. कंडेंसर का रोल क्या होगा, कंडेंस करना, यानी जितने भी यहाँ से वो हीट होकर वेपर्स आ रहे हैं उस कंपाउंड के, वो क्या करेगा, यहाँ जाकर कूल हो जाएंगे, तो यानी वो कंडेंस हो जाएंगे, और यहाँ से वो निकल के कहाँ चला जाएगा, बीकर में और कोनिकल में, जहाँ पर आपका प्योर कंपाउंड होगा. यहाँ पर आपको कंडेंस करने के लिए क्या करना पड़ेगा, आइस दे सकते हो, आइस नहीं देते हम वाटर देंगे, ठीक है. यहाँ पर आप वाटर इनलेट लगाओगे और यहाँ पर वाटर आउटलेट। कंडेंस हो गया, यहाँ पर वेपर्स आए, कंडेंस होकर प्योर कंपाउंड यहाँ पर मिल गया। यहाँ पर आपका क्या रह गया, इम्प्योरिटी जो भी थी, ठीक है, या तो वो सॉलिड हो सकती है या फिर वो लिक्विड भी हो सकती है, ठीक है। डिस्टिलेशन, ये था प्योरली डिस्टिलेशन। लेकिन क्या ऐसा भी तो हो सकता है ना कि मेरे पास दो ऐसे कंपाउंड है जिनका बॉइलिंग पॉइंट थोड़ा थोड़ा पास पास है, से 273 और 283, ठीक है, क्वाइट क्लोज। तो उसके केस में मैं क्या करूँगी, आप लोगों ने फ्रैक्शनल डिस्टिलेशन पढ़ा है, सॉरी 273 नहीं, 373 एंड 383, ठीक है। सो आपने फ्रैक्शनल डिस्टिलेशन पढ़ा है। फ्रैक्शनल डिस्टिलेशन में क्या होता है, आप लोगों ने शायद वो पेट्रोलियम की रिफाइनरी में पढ़ा है। पेट्रोलियम की रिफाइनरी में आप क्या करते हो, जितने आपको पेट्रोलियम से क्या क्या मिलता है, पेट्रोल, डीजल, कैरोसिन, जहाँ तक अभी हमारे पास वर्थ है, एलपीजी और सीएनजी, ठीक है, ये सब मिलता है। इन सब के जो बॉइलिंग पॉइंट है या फिर इग्निशन टेम्परेचर है, दे आर वेरी क्लोज। तो अब उस केस में क्या करोगे, आप उसको अलग अलग कैसे करोगे, नहीं, उसके केस में हम क्या करेंगे, वील टेक अलग अलग तरीके से परफोरेशंस लेंगे, इनको कहते हैं थ्योरेटिकल प्लेट्स। व्हाट इज वेपर प्रेशर, सपोज आई एम कीपिंग अ बीकर ऑफ वाटर, ठीक है, यानी अब उस टाइम पे जो भी वाटर वेपर्स इस सरफेस के ऊपर हैं, ठीक है, वो जो प्रेशर एक्सर्ट कर रहे हैं, दिस इज नोन एज वेपर प्रेशर। दैट इज एनी प्रेशर अबव द लिक्विड, अबव द सरफेस ऑफ द लिक्विड इज नोन एज वेपर प्रेशर ड्यू टू इट्स वेपर्स। सो अगर मैं कह रही हूँ कि यहाँ पर कोई भी चीज़ कब बॉयल करती है, जब वेपर प्रेशर ऑफ दैट लिक्विड इज इक्वल टू द एटमॉस्फेरिक प्रेशर, ठीक है। यानी अगर मैं कह रही हूँ कि मेरा एक का बॉइलिंग पॉइंट है 373 केल्विन और एक का है 383 केल्विन, ठीक है। आई स्टार्ट हीटिंग, यहाँ पर जैसे मैंने यहाँ पे हीट करना स्टार्ट किया है, सपोज करो यहाँ पर वो कंपाउंड है 373 और 383 वाले, तो क्या होगा, दोनों हीट करना स्टार्ट करेंगे, दोनों के वेपर्स ऊपर जाना स्टार्ट करेंगे। लेकिन मैं चाहती हूँ कि पहले कौन सा जल्दी हीट होगा, 373 वाला, तो यानी उसके वेपर्स जल्दी फॉर्म होंगे, यहाँ पर जल्दी फॉर्म होंगे तो जल्दी ही कंडेंस भी होंगे। तो इसीलिए मैं चाहती हूँ कि पहले मेरा, इसको अगर मैं नेम करती हूँ ए और इसको बी, ठीक है, तो मेरा पहले ए कंपाउंड पहले वो होगा, कंडेंस होगा, तो मैं उसको इस तरीके से हीट करना स्टार्ट करूँगी कि पहले ए ऊपर जाएगा फिर बी जाएगा, लेकिन इन द मीन टाइम के पहले ए जाएगा, जितना ए मेरे पास आया मैं उसको कलेक्ट कर लूँगी, ठीक है। सो इस तरीके से अगर मैं इसको, इस डायग्राम को सिर्फ इतने पार्ट को अगर आप यहाँ से समझो, ठीक है, तो यहाँ पर क्या कैसे होगा कि मैंने हीट किया, वो थोड़े से वेपर्स ऊपर गए ए और बी के, फिर वो ऊपर गए, फिर वो ऊपर गए, फिर वो ऊपर गए, जैसे जैसे ऊपर जाते जा रहे हैं टेम्परेचर बढ़ रहा है, कम हो रहा है, कम हो रहा है, तो इसका मतलब अगर ए और बी ऊपर ट्रैवल कर रहे हैं, ठीक है, तो कौन सा ज़्यादा ट्रैवल करेगा, ए, ठीक है, तो यानी ए ज़्यादा ऊपर पहुँच पाएगा, यानी ऊपर जाकर वो कंडेंस हो जाएगा, ठीक है, एज़ कम्पेयर टू बी। बी जैसे जैसे थोड़ा थोड़ा ठंडा होता जाएगा, वो अपने बॉइलिंग पॉइंट से नीचे आ जाएगा, यानी वो वापस क्या कोशिश करेगा, लिक्विड बनाने की। ओके, देखो अगर मैंने कहा कि ए और बी दोनों ट्रैवल कर रहे हैं, ठीक है, ए का बॉइलिंग पॉइंट इज ग्रेटर, सॉरी इज लेसर, ठीक है, तो वो जल्दी वेपर ऊपर बनाएगा, तो वो जल्दी कोशिश करेगा कि उसके वेपर्स कंडेंस होकर कंडेंस हो जाएंगे, ठीक है। अगर मैं कह रही हूँ इस यहाँ पर से इसको ना समझ के इतने पार्ट को सिर्फ यहाँ पर से समझो, ठीक है, मैंने उसकी जगह ये बनाया, मैंने यहाँ पर ये सारे कैप्स बनाए हैं, यहाँ पर क्या है, टेम्परेचर डिफरेंस है, जितना ज़्यादा, अगर मैंने यहाँ से हीट करना स्टार्ट किया तो यहाँ टेम्परेचर ज़्यादा है या यहाँ पर ज़्यादा है, इसका मतलब यहाँ पर कम है, तो यहाँ पर कौन सा चीज़ वेपर में एग्जिस्ट कर पाएगी, ए या बी, ए, क्योंकि वो कम पर भी वेपर में रह सकता है, ठीक है, तो यहाँ पर सबसे ज़्यादा मेरे को क्या मिलेगा, ए को मैं कलेक्ट कर सकती हूँ, और जैसे जैसे नीचे आऊँगी तो यहाँ पर किसकी पॉपुलेशन ज़्यादा होगी, बी की। तो यानी अगर मैं इस तरीके का एक सेटअप बना लेती हूँ जहाँ पर मैं अपने कंपाउंड को कलेक्ट कर सकती हूँ, डिफरेंट जगह पर मैं उसे कंडेंस कर सकती हूँ, यहाँ पर मैं कंडेंसर लगा दूँगी, डिफरेंट जगह पर मैं आई पुट सम कंडेंसर, ठीक है। तो यहाँ पर जो सबसे ऊपर होगा मेरे पास उसके क्या होगा, प्योरली ए। जैसे जैसे थोड़ा थोड़ा नीचे जाऊंगी उसमें ए और बी दोनों होंगी, और सबसे नीचे कौन सा होगा, बी ही होगा, ठीक है। ए और बी दोनों हो सकते हैं। अब सपोज करो यहाँ पर बी, ये वाला मेरे पास प्योर ए मुझे मिल गया, ठीक है। उसके बाद मैं क्या करूँगी, ए और बी को दोनों को उठाऊंगी, दोनों के मिक्सचर को, उसको दोबारा से हीट करना स्टार्ट करूँगी। फिर से क्या होगा, फिर से ए ऊपर पहुँच जाएगा और बी थोड़ा नीचे नीचे रहेगा। इस तरीके से मैं धीरे धीरे स्टेप बाय स्टेप आई विल डू, ए को सेपरेट कर लूँगी, पूरा ए प्योर मिल जाएगा मुझे, और जो रेस्ट बचेगा वो क्या होगा, बी होगा। पानी क्या 100 पर बॉईल करके 130 पर एग्जिस्ट नहीं करता, होता है ना। इसका मतलब है उस टाइम उसका वेपर प्रेशर इक्वल हो गया है, उसके बाद वो वेपर्स बनना स्टार्ट हो जाएंगे। लेकिन हम ये नहीं कह सकते कि उसका लिक्विड फॉर्म एग्जिस्ट नहीं करता, ठीक है। वेपर्स उस टाइम भी रहेंगे, बस ये है कि वेपर्स थोड़ी और ज़्यादा टेम्परेचर होगा उनका, क्योंकि उसका वेपर प्रेशर, अगर उसका बॉइलिंग पॉइंट कम है तो इसका मतलब वो जल्दी वेपर बना लेगा, ठीक है। जल्दी वेपर बनाएगा तो वो जल्दी ऊपर ज़्यादा जल्दी जाएगा। लाइटर एयर हमेशा क्या होती है, ऊपर जाती है। तो वेपर अगर जल्दी बन रहे हैं तो वो ऊपर जाएंगे, क्योंकि बी वाले के वेपर धीरे धीरे बन रहे हैं अभी, क्योंकि उसका बॉइलिंग पॉइंट कम ज़्यादा है, तो इसलिए वो धीरे धीरे ऊपर जाएंगे। लेकिन पहले कौन चले जाएंगे, ए वाले, जल्दी कूल हो जाएगा। क्योंकि देखो मैंने उसे यहाँ पर से हीट करना स्टार्ट किया, ठीक है। उसके बाद वो यहाँ पर भी पहुँच सकता है, ए और बी। आई मेक अ नीटर डायग्राम, ठीक है। सपोज करो दिस इज द डायग्राम, ठीक है। यहाँ पर मैं उसे हीट कर रही हूँ, ठीक है। यहाँ पर से दोनों ट्रैवल करेंगे, ए भी ट्रैवल करेगा और बी भी ट्रैवल करेगा। यहाँ पर टेम्परेचर इस टाइम क्या है, सपोज करो आई स्टार्टेड हीटिंग फ्रॉम 373, उसके बाद मैं 400 तक उसे हीट कर रही हूँ। तो सबसे पहले कौन हीट होगा, सबसे पहले वेपर कौन बनाएगा, ए बनाएगा सबसे पहले। ए के वेपर, और उसे टेम्परेचर दे रही हूँ तो वेपर्स कहाँ जाएंगे, ऊपर 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 जाते जाएंगे। यहाँ पे सब पे जगह मैंने पे कंडेंसर लगा रखा है। जितने भी ये प्लेट्स हैं इसलिए क्यों है ये प्लेट्स, ताकि आपको कंपाउंड कलेक्ट कर सको, ठीक है। आपको सेपरेट करना है ना, आपको सिर्फ हीटिंग थोड़ा ना करनी है, यू नीड टू कलेक्ट दोज कंपाउंड, ठीक है। तो आप क्या करोगे, पहले ए हीट हो जाएगा तो ऊपर ट्रैवल कर जाएगा, बी भी एकदम से, उसके बाद जैसे ही 383 टेम्परेचर पहुंचेगा बी भी साथ में अब वेपराइज करना शुरू करेगा, ठीक है। उसके वेपर्स भी ऊपर जाएंगे। लेकिन जैसे जैसे ऊपर जाते जाते हैं टेम्परेचर जो है कम हो रहा है, ठीक है, क्योंकि हीट यहाँ पर मैं उसे दे रही थी, यहाँ पर उसके पास हीट नहीं है। जैसे ही हीट मिली वो वेपर बन के ऊपर तो चले गए, लेकिन अब टेम्परेचर धीरे धीरे वहाँ पर कम भी हो रहा है, तो अब वो कंडेंस करना स्टार्ट करेंगे। तो पहले कौन कंडेंस कर पाएगा, यहाँ पर ए कर पाएगा, और यहाँ पर कौन कर पाएगा, बी, क्योंकि जैसे ही उसे 383 से ज़रा सा भी टेम्परेचर कम मिला तो वो कंडेंस हो जाएगा। दिस इज द केस ना, समझ में आया। दिस इज नोन एज फ्रैक्शनल डिस्टिलेशन, क्योंकि आप इसमें फ्रैक्शंस यानी दो कंपोनेंट्स जो कि सिमिलर नियर अबाउट बॉइलिंग पॉइंट है उसको आप सेपरेट कर रहे हो, दो फ्रैक्शंस को, ठीक है। और यहाँ पर आप ये प्लेट्स बना रहे हो कलेक्ट करने के लिए। दिस इज द सेम फंडा फॉर द पेट्रोलियम रिफाइनरी, बिकॉज उसमें जितने कंपोनेंट होते हैं उनके बॉइलिंग पॉइंट नियर अबाउट सेम होते हैं। तो आप लोगों ने स्कूल में डायग्राम पढ़ा था 10th में कि ये प्लेट्स वहाँ पर ऐसी बनी होती हैं। फ्रैक्शनेटिंग कॉलम किसको कहते हैं, ठीक है। दिस इज अ सॉर्ट ऑफ कॉलम ना, ठीक है। दिस इज नोन एज फ्रैक्शनल डिस्टिलेशन। देयर इज वन अनदर कंसेप्ट ऑफ रिड्यूस्ड फ्रैक्शनल डिस्टिलेशन और डिस्टिलेशन अंडर रिड्यूस्ड प्रेशर। उसमें क्या हो सकता है, यानी अगर मैं कहूँ कि किसी एक कंपाउंड का बॉइलिंग पॉइंट है 373 केल्विन, लेकिन अगर मैं उसे वहाँ तक बॉयल करूँगी, यानी बॉइलिंग पॉइंट पे बॉयल होगा ना, लेकिन अगर वो वहाँ तक पहुँचने से पहले ही डीकम्पोज हो जाता है, ठीक है, तो उस केस में मैं क्या करूँगी, उसको तो यानी मैं कभी प्योर फॉर्म में ले ही नहीं सकती। तो उसका क्या तरीका है, क्योंकि बॉइलिंग पॉइंट एक वो चीज़ होती है वेयर द वेपर प्रेशर इज इक्वल टू द एटमॉस्फेरिक प्रेशर। तो यानी अगर मैं उस प्रेशर में उसे अपने आप को लेके आना है, यानी अगर मैं एटमॉस्फेरिक प्रेशर को ही कम कर दूं तो इसका मतलब वो जल्दी बॉयल हो जाएगा ना। ऑल्टीट्यूड्स पे क्या होता है, पानी जल्दी बॉयल होता है, क्योंकि वहाँ पर ऑल्टीट्यूड्स पे प्रेशर इज लेस, प्रेशर लेस होता है तो इसका मतलब एटमॉस्फेरिक प्रेशर लेस है तो इसका मतलब वेपर प्रेशर भी आपको लेस चाहिए होगा, ठीक है। अगर आपको एटमॉस्फेरिक प्रेशर लेस चाहिए तो आपका वेपर प्रेशर भी कम होगा, कम चाहिए होगा आपको, ठीक है। तो आपका टेम्परेचर भी कम हो जाएगा। यानी अगर पानी यहाँ पर सरफेस पर 100 डिग्री सेल्सियस पर बॉयल होता है तो ऑल्टीट्यूड्स पे इट्स लाइक 75 या 80 पर वो बॉयल हो जाएगा, ठीक है। तो अगर मैं चाहती हूँ मेरा कंपाउंड बॉइलिंग पॉइंट तक पहुँच नहीं पाएगा, उससे पहले डिकम्पोज हो जाएगा, तो इसका वे आउट क्या है दैट कि मैं प्रेशर को यानी एटमॉस्फेरिक प्रेशर को ही रिड्यूस कर दूँ। तो उसके लिए मैं क्या करूँगी, मेरा ये सेम सेटअप होगा, ठीक है, सिर्फ एक चीज़ डिफरेंट होगी कि यहाँ पर मैं उसे एक रिड्यूस्ड प्रेशर दूंगी, ठीक है। किसी ने कभी सक्शन प्रेशर सुना है? सक्शन प्रेशर, ठीक है। बहुत बार ऐसा होता है कि फिल्ट्रेशन जब आप करते हो तो फिल्ट्रेशन इज़ वेरी स्लो। इन दैट केस आपको क्या चाहिए होता है, एक आप यूज़ करते हो एक बूकनर फनल, ठीक है। इट इज़ परफोरेटेड। आपके पास जो यूजुअल फनल होता है वो क्या होता है, ग्लास का होता है, यही होता है ना, ठीक है। लेकिन जहाँ पर फिल्ट्रेशन बहुत स्लो है, स्लो फिल्टर हो रहा है, तो उसके केस में आप नॉर्मल फनल यूज़ ना करके यू यूज़ बूकनर फनल, ठीक है। बूकनर फनल को यूज़ करने के लिए क्या फंडा है कि आपको साथ में एक प्रेशर अप्लाई करना पड़ेगा, यानी आप उसका प्रेशर जहाँ पर वो चीज़ आ रही है वहाँ से खींच रहे हो, सक्शन अप्लाई कर रहे हो, ठीक है। जस्ट लाइक वैक्यूम क्लीनर कैसे एक्ट करता है, आप उसका प्रेशर रिड्यूस करते हो ना, आप जहाँ पर भी डस्ट होता है आप उसे वहाँ से खींच लेते हो, ठीक है। सिमिलरली बूकनर फनल में जब आप उसे किसी भी चीज़ को ऊपर से डालोगे, ठीक है, फिल्टर करोगे, उसके बाद आप यहाँ पर से प्रेशर अप्लाई करते हो, रिड्यूस कर देते हो प्रेशर को, ठीक है। यू रिड्यूस दिस प्रेशर। जिससे कि वो बूकनर फनल में से आने वाली चीज़ जल्दी फिल्टर होती है। प्लीज एक्सप्लेन इन इंग्लिश। ओके, इज सक्शन प्रेशर क्लियर टू यू? Let's again start with distillation under reduced pressure. We are saying that what is distillation under reduced pressure? This distillation is carried out for the compounds which decompose before their boiling point, and hence I'll take the same setup as that of distillation. I'll take the mixture in the round bottom flask and start heating it and pass the vapors into the condenser as usual, and then collect those vapors in the conical flask. This is the condenser. So what happens in the distillation under reduced pressure, that instead of using the atmospheric pressure, I'll reduce this pressure by using suction. But we are not getting the temperature of, we are not reaching this temperature 373 Kelvin. I am reaching a lesser temperature, because just suppose if its boiling point was 473 at 1 atmosphere, but I am saying that here in this flask there is a pressure of say like 0.5 atmosphere. If the pressure has changed, then the boiling point would also change. If earlier it was 1 atmosphere, but now it is 0.5 atmosphere due to suction because due to the reduced pressure, the vapor pressure would also decrease, and hence the boiling point would also decrease. So earlier if the compound was boiling at 473 Kelvin, but now it will boil at some 273 or 373 Kelvin. No, this is the purest form of the compound. You do not require any further purification of the compound. This is the purest form of the compound. Okay. The reduced pressure was here only. in this flask only. How this is reducing the boiling point? Because okay, so just suppose there the vapors are the liquid has started boiling. ठीक है, they have not started actually boiling till now. You can apply the suction from here also, so that under it, why you are saying that this is the distillation under reduced pressure? Because if I want the liquid to boil at lesser temperature, say 273 Kelvin, just suppose if I am saying, or say 373 Kelvin, the pressure should be less. Then in that case, what do you expect? The pressure should, this way is also right, that I can also reduce the pressure here, because ultimately the liquid which is being condensed is collecting in the reduced pressure, because in the reduced pressure the ultimately the water vapors, sorry, the liquid vapors will fall into this conical flask. So उसे अगर जहाँ पर मैच करना है, that would be in the flask only. So basically we have studied 4 types of distillation, three type of distillation. First is purely distillation, second is fractional distillation, and distillation under reduced pressure, and the fourth is steam distillation. Have you heard about steam distillation? What is steam distillation? Steam distillation is used for the compounds or mixture which have very high boiling point, or which are otherwise non-volatile, or which are volatile with steam. What do I mean by this non-volatile and volatile by steam? That means they are not volatile as such, but when I apply some steam over it, it will volatile. So what is the concept of steam distillation? I'll take the impure compound. Okay, I'll take the impure compound, that means a mixture of two compounds having a compound and impurity into it, right? So I'll start heating it. I'll pass some steam over it. I'll draw. I'll take the impure compound or the mixture of the compounds and pass some steam over it on the vapors of the compound. These two mixture of the compound will pass through the condenser and I'll get the compound plus water. But if I am saying that I want to obtain a pure compound, then how can I say that pure compound contains water? Then in that case it is not a pure compound. But steam distillation is only valid for the case where the compound is immiscible with water. So these are the various criteria for which steam distillation is applicable. Immiscible with water, it should be non-volatile, or it should be volatile with steam, or where the compound has high boiling point. Sorry? steam distillation with volatile, in that case I think you should use sublimation. Depending on the kind of the compound you are separating, you should decide what kind of purification technique you should apply. If I am saying that my mixture contains a compound which can be distilled, but other compound can be sublimed, so it's better I would sublime the compound, or I'll distill the compound, another compound, and I'll be left with the compound which can be sublimed. So that way I can, by applying two procedures side by side, I can separate both the two components, A and B both. In this case, these are the criteria for steam distillation. So what happens that in steam distillation, I am saying that suppose I am taking water along with the compound. I know they both have some vapor pressure. They have individual vapor pressure which would be equal to the total vapor pressure. If I am saying that the vapor pressure, where does the water boil? At what temperature? 100 degrees Celsius, that means 373 Kelvin. Let it be, let the boiling point of the other compound which I am trying to separate, let it be some X, let it be P2. So that's for sure that the vapor pressure of the compound would be greater than 373 Kelvin. So that means I want a temperature जहाँ पर the compound will evaporate at 373 or below it, because I don't want the compound to decompose before it reaches its boiling point, because I am saying that it is non-volatile. Okay, so I want कि the vapors should start forming before its boiling point. So I'll take the compound or the mixture having compound and the impurity, and I'll introduce the steam, high temperature steam into it, and then the steam, that means water vapors and the compound vapors, will start combining and they'll condense and get collected into the beaker or conical flask, because I am saying that the compound is immiscible with water. So that way I can just evaporate the water, or I can separate using some differential extraction. What is differential extraction? Any idea what is differential extraction? Do you know organic compound does not mixes with aqueous compounds. Organic compounds are immiscible with aqueous compounds. Sorry. This method is used to obtain the pure compound that should be immiscible with water or having high boiling point. The main aim of using this steam distillation process is that suppose this compound has very high boiling point, but I cannot provide that much heat to the compound. For some constraints, I'm not able to provide that much heat to that compound. So that in that case, I'll introduce some steam into it, and instead of providing that temperature at which it actually boils, I'll be able to separate out the compound without reaching that exact temperature. And how is it possible? I know according to Dalton's law that the total pressure is P is equal to P1 plus P2, that means individual vapor pressure. That means if I am saying that this flask has compound and the water, that means each of them will exert their own vapor pressure. That means यहाँ पर जो pressure है that would be greater than the individual vapor pressure. That means if this compound wants to get boiled, that means it has to reach this much vapor pressure. And suppose I am providing this temperature to it, instead of जो इसका individual vapor pressure है, compared to this vapor pressure is always greater, and hence when I start heating it, this compound will eventually start vaporizing. What is boiling point? Boiling point is the temperature at which the atmospheric pressure, or I'll say the external vapor pressure, atmospheric pressure is equal to vapor pressure. This vapor pressure is greater due to the combination of water and the compound as compared to the individual vapor pressure. So due to the combined vapor pressure, according to Dalton's law, this compound will start boiling before its actual boiling point. because I have increased, I have changed the external conditions. I have provided that atmosphere that okay, this is now the increased vapor pressure, now you can boil easily. Okay, this was the case for steam distillation. This is only valid when these conditions are fulfilled. So basically we have studied 4 types of distillation: simple distillation, fractional distillation, fractional under reduced distillation under reduced pressure, and steam distillation. Another kind of technique which is used is differential extraction. What is differential extraction? Has anybody seen the separating flask in the lab? Separating flask. How does it look like? It looks like this. Here you have a knob and this is a cork. This is how the separating funnel looks like. This technique is used when the compound I tend to separate is soluble in some organic layer and as well as in aqueous layer. Suppose I am given a compound A with the water. I am saying this beaker contains A plus water and I want to separate A from the water. But I know this A is also soluble with some organic liquid, say like CCl4, and still I want to extract A compound. So what will I do? I will take that compound of A plus water in the separating flask and then I will put another liquid above it, which is the organic compound of CCl4. I know this compound A is soluble both in water as well as in organic in CCl4, but I know that this compound is more soluble in CCl4 in the organic layer. So what I have done, I have taken that impure mixture and I have taken another organic compound in which that compound which I tend to extract is more soluble in the organic layer. So I will take that organic compound above the aqueous layer and I will from this side and I will close it from the lid and I will start shaking it. After shaking it for some time, the scenario would be opposite. That means now I will have this aqueous layer at the bottom and the aqueous layer above it. Or it's not necessary, but this is the case that I know that A will tend to dissolve more in the CCl4 layer and hence it will try to get into the CCl4 layer. Now I can say that there is less amount of A in the water layer. It does not imply that the water does not have A, but it does mean that the organic layer has more amount of A in it because A is more soluble in CCl4. Okay, but make sure this does not imply that this does not imply that the water layer does not have A. Water layer does have A because A was soluble both in water and CCl4. So what I will do, now the two layers are separate. I know that the A compound is more soluble in CCl4. It is present in more quantity in the CCl4 layer. I will open this knob. I will open this knob and I will separate this organic layer from the aqueous layer. It will go step by step and then I will be left with just, and as soon as I reaches this aqueous layer at the bottom, I will just close the knob. Okay, I will close the knob so that I will be left with the aqueous layer only. So that ways I have extracted my compound A into the organic layer. Okay, so now what do I do if I want to extract A from organic layer? What is the other way? If I want to separate A from the organic layer, what do I do? Heat, or I can what I can do? I can heat it. Maybe the this compound I can distill it. I can also distill it. I know this has a specific boiling point, so I can distill off this organic liquid and I'll be left with this pure compound. So basically purification of organic compound combines a lot of experimental techniques all together, not just one technique at a time, but all together. Suppose I'll first take some differential extraction technique using this. This is known as separating funnel, because I am separating the organic layer and aqueous layer, right? This is the separating funnel. So I'll first use the separating funnel or differential extraction technique, then I'll go for distillation. This was the fourth technique of differential extraction. The another technique for purification of compound is chromatography. What is chromatography? Depending on the different chromo means color and graphy means, say like just like you draw different lines on the paper, it is like separation, or you can more vaguely say separation on the basis of color. Earlier this technique was the person who designed this technique was used to separate the components of the plant which were colored, and hence the name was devised as chromatography. But on the various colored components, you can say colored compounds of flowers. Why different flowers have different colors? They were used to separate the colored components of the plants. Earlier this was the history of the chromatography, but later on it was used to separate various chemical compounds. Example is separation of amino acids. We know lysine, glycine, these are the various amino acids. I can separate mixture of these amino acids using chromatography. So there are basically two types of chromatography. One is adsorption, another is partition. Adsorption chromatography again is of two types, column chromatography and thin layer chromatography. Have you ever performed any chromatography in school?
Yes.
What was the setup? What did you extract? You separated the mixture of inks? Okay. So what did you do? What is RF value? Let's take each chromatography step by step. Adsorption chromatography means on the basis of adsorption of the adsorbate. What is adsorbate? A one which itself gets adsorbed. Suppose I am wiping off some blood with the cotton, then in that case blood is the adsorbate, while the cotton is adsorbent. One which adsorb is adsorbent. So the chromatography, first type of chromatography is adsorption chromatography, which can be further classified into column chromatography and thin layer chromatography. What is column chromatography? In this chromatography, you will take some adsorbent. It could be any silica gel. You know silica gel are adsorbents. You would often find silica gel lying inside your newly purchased bags or shoes. Okay, silica gel or alumina. You will take a sheet or a layer of adsorbent, and you will this is known as The which absorbs is known as absorbent. This is known as stationary phase, because this is unmovable, this does not move. While the one which I run through it, any solvent which I run through it, in your case you have taken water as the moving phase. What did you do? You have taken some ink you put some ink spots on the chromatogram, and you have applied that water, you have inserted that chromatogram into the water, and the water would travel along the chromatography strip. So what happened, that this adsorbent, that means your chromatogram was a stationary phase, adsorbent was a stationary phase, while the moving liquid, which actually separates the two layers or any amino acids or two ink, these are known as moving phase. So in that case in which you have separated two inks, water acted as a elutant, and this process is known as elution. Elutions means to extract, elute, to separate. Getting? Elutant, which separates the two components or via some adsorbent. Suppose I am taking this a stationary phase. I know I have to separate these two inks, say like blue and red ink, from each other. So I'll put a mixture of blue and red ink on the stationary phase, on the filter paper, on the Whatman. What do you use? A Whatman filter paper. Not a usual filter paper, but Whatman filter paper. This is specially designed for chromatography. You will take a Whatman filter paper which will act as an adsorbent. You will put those spots, you will just put a, I want to just separate those components. I'll take one spot of mixture of blue and red ink to it. Now I want that these two components should separate out, but they cannot get separate out itself, so I have to apply another moving phase to it. ठीक है, मुझे उसे सेपरेट करने के लिए क्या करना पड़ेगा, कुछ और भी देना पड़ेगा, एड्सॉर्बेंट कुछ इनिशिएट करवाने के लिए. सो इफ आई वांट टू इनिशिएट द एड्सॉर्प्शन प्रोसेस, देन आई विल पुट सम मूविंग फेज और सम सॉल्वेंट इनटू इट, सो दैट वेज दिस स्पॉट विल स्टार्ट मूविंग, यानी अब वो इंक सेपरेट करने लगेंगी. ठीक है, सपोज इफ आई पुट सम, आई विल टेक सम पेट्री डिश. Okay, I'll take some petri dish, and in this I'll put some water, and I'll keep the tip of the Whatman filter paper into this water, just tip of it, because I want that the adsorbent should start absorbing the water so that it can go along the filter paper, because water is responsible for separating the ink. Okay, this water will be absorbed by the Whatman filter paper, and as soon as this reaches this ink spot, it will go and it will separate those two inks. Why water will tend to separate the ink? What is the criteria? Why blue ink and red ink will separate? They are miscible. What is the reason? Because both the ink, I am taking only those compounds which have differential solubility with the water. I am saying that the blue ink will dissolve to a different extent as compared to the red ink, or I'll also say that the blue ink get retained on the adsorbent differently as compared to the red ink. That means I'll say that the blue ink has more affinity, it has more stability towards the adsorbent as compared to red ink. So that means if I'll start if I put this water, if I put the filter paper in the water, then as the water will be able to use as an elutant, the water will travel upside, and why the blue ink will stay here only, and why the red ink, why the water will take the red ink upside? What is the reason? What could be the reason? I just told you. Solubility, because water has different solubility with blue and red ink, and also The blue and red ink has differential adsorption capacity to the adsorbent. That means if I am saying कि blue अभी भी यहीं पर है and red is travelling, that means red has lesser affinity to the adsorbent. It can travel again. Then that means elutant means to separate. So water is able to separate the ink from that spot to the upside. This is the concept of chromatography. So what happens in the adsorption chromatography, in the column chromatography? I'll take a column, say it can be silica gel. I'll take a column which will act as adsorbent. Okay, then I'll take the mixture of say like A, B and C components, and I want to separate A, B and C. Okay, I'll take this column of the adsorbent and I'll put that mixture of A, B, C component. I'll introduce that mixture into the column. Suppose I have introduced this mixture as a slurry. That means अभी वो वहाँ पर stationary है, अभी just वो मैंने उसको spot किया है, ठीक है, mixture बनाकर I have spotted it. I'll start putting some elutant to it. यानी अब suppose यहाँ पर मैंने एक adsorbent लिया, यहाँ पर उसे fix किया, the components I want to separate, and then I'll start moving the elutant towards the adsorbent. Now according to the affinity of the adsorbent of the component towards the adsorbent and the solubility of the mixture of the components in the elutant will decide the position of the components. A will travel more or B will travel more or C will travel more. So that means if I am saying this is A, this is B and this is C, that means A will elute first, then B and then C, depending on the different solubility as well as affinity towards the adsorbent. Most which is more soluble, one which is more soluble will elute last. जो सबसे ज़्यादा soluble होगा वो सबसे ज़्यादा last में solvent का साथ छोड़ेगा, ठीक है. That means if A is getting separated out first, that means it had lesser affinity to water, lesser affinity to the solvent I can say, or elutant I would say. It has lesser affinity to the elutant and hence it has left the elutant. Later B has separated out, that means it has greater affinity as compared to A but lesser affinity as compared to C. C has eluted the last, that means it had the highest affinity towards the elutant. So this way I can separate different components using chromatography, and I have obtained the purest form of the compound. Okay. So this you can also use the retention factor. RF means retention factor. How do you find retention factor? What is retention factor? The more the compound stays at the adsorbent, it is known as retention factor. What is retention factor? It is the distance travelled by component A over distance travelled elutant, और जहाँ पर आपका starting point, from the starting point. That means if I put the dot over here and the compound has travelled till this distance, suppose I mark this as 0 and I have seen that this is the x and B has travelled this is y. So that means retention factor for A would be A over, suppose this was some length of say 3, A by 3 for the A, and for B it would be x plus y by 3. Okay. So these were the various purification techniques. So what all the techniques we have studied? Filtration, sublimation, distillation and differential extraction and chromatography. Okay. Now we want to identify the compound. All of you must prepare the Lessines extract in the lab. This is known as qualitative. We know the quality of the organic compound. Qualitative identification. Organic compounds could be covalent or ionic. So let's suppose if I am taking any organic compound, it is covalent in nature, and I want to know whether it contains nitrogen, carbon, oxygen or phosphorus or sulphur or any halogen. So what do? I'll take that covalent compound and I'll fuse it with the sodium metal. I'll take some covalent compound and fuse it with sodium metal. What is the purpose of fusing the covalent compound or organic compound with the sodium? Because this way, because this way covalent compound will get converted into anything which is covalently bond will get converted into ionic form, because ionic form is easy to differentiate. I can identify the whenever the compound is in ionic state, it will readily react. I know why NaCl readily dissolves in water, because it is ionic, because covalent molecules take time to dissociate, because covalent molecule is the strongest bonds. Covalent bond is the strongest bond. So if I want to identify, qualitatively analyze the organic compound, I'll try to convert the covalent compound into ionic form, and that is why I'll take the organic compound and fuse it with the sodium metal. This way I'll get the ionic form of the compound. I'll get the ionic form in which nitrogen, carbon, sulphur and oxygen, phosphorus and halogen would be present. Alright. So first is why this is known as Lessines extract. So how do we prepare Lessines extract? I'll take some organic compound, any fusion tube. These are very small fusion tubes. I'll take some sodium metal into it, very small piece of sodium metal to it, and start heating it to a silver globule. यानी उसे तब तक हीट करूंगी जब तक वो एक शाइनी सिल्वर ग्लोब्यूल में कन्वर्ट नहीं हो जाता. ठीक है, तो एक बार सिल्वर ग्लोब्यूल में कन्वर्ट हो गया, देन I'll put some I'll add some organic compound to it, just a pinch of organic compound using spatula. Okay, then again I'll start heating it. This way the organic compound will get converted into ionic form. Okay, then I'll heat it, and then I'll put this heated fusion tube into the china dish, which has been covered. Okay, I'll plunge this fusion tube into the china dish containing water, because I want कि अब वो सारा soluble form किसमें चला जाए, into the water. I'll take some 3-4 fusion tubes and I'll repeat this procedure and plunge these fusion tube into the china dish, and then I'll just break those fusion tubes and start heating it to get a concentrated extract, and this was known as Lessines extract. I'll take a small fusion tube and put a small piece of sodium metal to it, and then I'll start heating it until it has changed into silver shining globule. Okay, then I'll add some organic compound to it, a pinch of organic compound to it, and then I'll again heat it. Okay, then I'll plunge this fusion tube into the china dish containing water. That means उसमें आप heat करके जल्दी से उसको उसमें डाल दो और cover कर दो. ठीक है, ऐसे this procedure I'll repeat it for 3-4 times so that I can get enough amount of organic compound in the ionic form. Okay. Now I'll start heating this extract and then I'll filter out. This is known as Lessines extract. This Lessines extract is basic in nature. Why basic in nature? Why not acidic? Because it contains sodium metal. So sodium metal will combine with water to form NaOH. So hence this is sort of a basic extract. So how do we proceed next? So I'll start identifying for various elements, extra elements present in the organic compound. What was the first test? Sodium cyanide, NaCN. That means any compound having carbon and nitrogen. Suppose you are taking any compound which contains carbon and as well as nitrogen. I don't know in which form it is present, but when I fuse that organic compound with the sodium, it will form the ionic compound as Na plus and Cn minus. Now that form is more easily I can easily identify this type of form for the carbon and nitrogen rather using amino group. I know there are various tests for identification of amine group, but I just want to check the compound for the nitrogen only, not for amino group. In that case, converting that covalent compound into ionic form like this is more easier, is more approachable. Okay, I just want to check for carbon, nitrogen and oxygen, not for the functional group. These are the functional group. I am saying I want to identify for the elements. These are known as extra elements. When you perform test for extra elements using Lessines extract, and when you perform test for these are known as functional group. These tests are different. Okay. What could be the first test for the identification of nitrogen? Let's take nitrogen. Test for nitrogen. So what I have been left with, मेरे पास अभी क्या बनाया मैंने? Lessines extract. Let it be represented by Le. Okay. What do you do for nitrogen? What test do you perform? You take freshly prepared ferrous sulfate solution and then you boil it. These are the various tests you must have performed in school, I am sure. No? Okay, some of you have done these experiments in the school, but what do you do for testing nitrogen? You will take small amount of Lessines extract into the test tube, just a small amount, 1 or 2 ml of the Lessines extract in the test tube and put some freshly prepared ferrous sulfate into it. Just a small amount, say 1 or 2 ml into it and then start boiling it. If you get then you will add few drops of ferric chloride. Ferric chloride and then concentrated HCl. If you obtain a Prussian blue color, Prussian blue color, in that case I would say nitrogen is present. If I do not obtain Prussian blue color, that means nitrogen is absent. Okay. So what could be the possible reactions that would have take place? If I am saying that the compound has nitrogen and I have combined this nitrogen with the sodium metal, it would exist as Na plus C plus N. I know this is an organic compound, that means carbon has to be present in it, that it is possible that it is present as NaCN. Then I have reacted this Lessines extract with the ferrous sulfate. What would be the reaction? NaCN plus FeSO4, sorry, this is NaOH. First it is basic in nature, na? So I have to consider the reaction with NaOH also. it would form ferrous hydroxide plus Na2SO4. Whenever you put this down sign, that means it is a precipitate. Sorry, ferric hydroxide and साथ में sorry I have written the wrong reaction. NaCN and H, NaOH. What would be the possible products? HCN, FeOH2, but I have to take sorry if I am taking FeSO4 and NaOH. It is FeOH twice plus Na2SO4. This ferrous hydroxide would react with NaCN to form ferrous cyanide precipitate, and this ferrous cyanide precipitate will again react with sodium cyanide to form Na4FeCN6. This is known as sodium ferrocyanide. These are very important reactions, and this sodium ferrocyanide would react with ferric chloride to form ferric ferrocyanide, which is blue in color. Ferric ferrocyanide. What was the reason for the blue color? Ferric ferrocyanide. This could be the important question from competitive exam point of view. Ferric ferrocyanide. So this was, the test looks simpler, that you take a Lessines extract, then add freshly prepared ferrous sulfate solution, concentrated HCl, then ferric chloride. But the reactions are a little complicated, but they are easy. Done. Next is the test for sulphur. For this, I'll take 1 to 2 ml Lessines extract, then add some acetic acid to it, and then add lead acetate. If I get a black PPT, black precipitate, that means sulphur is present. What could be the possible reactions for this? I am saying sodium plus sulphur would form sodium sulfide. Then this sodium sulfide would react with lead acetate to form lead sulfide, which is black PPT, plus CH3COO. This acetic acid was to provide a acidic medium to it. Because I know Lessine's extract is basic in nature, so to neutralize that basic nature, I have added the HCl. Sorry, I have added the acetic acid. Otherwise, the reaction is only with the sodium sulfide and lead acetate to form lead sulfide, which is black in color. Okay. Next we have another test for sulfur. This was the first test for sulfur. There's another test for sulfur in which I add sodium nitroprusside to it. What is the formula for sodium nitroprusside? It is again very important from exam point of view. This is Na2FeCN5NO. Na2FeCN5NO. This would react with Na2S to give a violet color compound, violet color or purple color. What is the compound form? Na4FeCN5NO. To neutralize, because I know Lessine's extract is basic in nature, so I have nullified that basic nature and then I have added this compound, because for this reaction I want the medium to be neutral. Any doubts? So basically there are two tests for sulfur, either by adding lead acetate or by adding sodium nitroprusside. Again, this compound formation which has taken place is very important. They could ask you what is the formula of the compound which is responsible for the violet or purple coloration in the sulfur test. You can name it as sodium. This is the external, this is the salt coordination compound, right? So you will name it as sodium ferro. What is the oxidation state for this iron in this? 3 or 2? X minus 5 plus 1 and 0. It is plus 2. You can find out the oxidation state in the coordination compounds, right? It is present in plus 2 state. It is ferrous cyano nitrous sulfide, sorry, sodium ferrous cyano nitrous sulfide. But most importantly, you should know the formula of the compound form. Next we have test for नाइट्रोजन एंड सल्फर प्रेजेंट टुगेदर. ये भी हो सकता है ना कि दोनों का एक साथ भी हम टेस्ट कर लें, रादर नाइट्रोजन एंड सल्फर इंडिविजुअल टेस्ट करने के वी वुड परफॉर्म अ कंबाइंड टेस्ट ऑफ नाइट्रोजन एंड सल्फर. फॉर दिस आई नीड for this the compound would exist as NaCNS, right? Because I know this is an organic compound, carbon would be present in any case. Okay, let the compound be present as NaCNS, then I'll add some ferric chloride to it, Le plus ferric chloride, and then I'll get a deep blood coloration. This compound is responsible for the deep blood coloration. So this test was way simpler than the individual nitrogen and sulfur test. But sometimes this test can be negative. What is the reason? Because maybe sulfur is not present or nitrogen is not present. If nitrogen and sulfur both are present, then only in that case that this test would be positive. If any of those nitrogen or sulfur is absent, then in that case this test would be negative. Understood? This is the possible reaction. Next we have test for halogen. Halogen test is the most simplest one. For that you will take a Lascine's extract and then add some concentrated nitric acid to it, then boil it, then cool it, and then add silver nitrate to it. ठीक है, so क्या बनेगा हमारे पास? Reactions लिखें पहले. Let the compound be present as NaX, because I am saying X is any halogen. It could be chloride, bromide or iodide. Okay. Suppose the compound is present as NaX. I am saying I am adding HNO3 to it. Then the reaction would be, what would be the reaction? NaNO3 and, okay, then I have boiled it, then I have cooled it, then I have added the silver nitrate to it. What would happen? Then AgX and HNO3 I'll get. So the halogen will precipitate as silver salt. It would exist as silver chloride or silver bromide or silver iodide. So depending on whether the chloride or the bromide or the iodide present, the color of the precipitate would vary. If I am saying that chloride is present, then the color of the precipitate would be white. If I am saying the bromide is present, the color of the precipitate would be pale yellow. If I am saying iodide is present, then the color of the precipitate would be bright yellow. Not much difference. But suppose if you are not able to make out the difference between these three, but actually the white precipitate is very much clear, pretty much clear, but how do we differentiate again? If I am getting the PPT and I am not able to differentiate whether it is chloride, bromide or iodide, but for sure halogen is there, then how do I differentiate? That this white PPT is soluble in ammonium hydroxide. Suppose I have performed the test, I have taken the Lascine's extract and I get this PPT after adding silver nitrate, and I am saying that I don't know whether it is chloride, bromide or iodide. I will put some ammonium hydroxide to the precipitate, and if it dissolves, then chloride is present. If it does not dissolve or it partially dissolves, then the bromide insoluble in slightly or insoluble, very slightly, but this chloride is completely soluble.
If it is insoluble in NH4OH, then how we have to differentiate from Br negative and ion?
That I am telling you. If I am saying it is, sorry, this is partially insoluble and this is completely insoluble. Why we are not taking? Because fluoride is extremely reactive. It does not give any fine test. There are other tests for fluorides, but this test is not. These are the very general tests for all the halogens, and that's why we have not included the fluoride test. Because fluoride, if I have fluoride here, what would happen? It would form HF, which is fluoric acid, hydrofluoric acid, right? Which is very reactive. आप लोगों ने पढ़ा होगा सिलिका के साथ. If I take HF, it would react with the glass tube, because hydrofluoric acid reacts with the glass of the borosill. Okay, because we do not want any compound which reacts with the glass of the apparatus, and hence we cannot perform the fluoride test. There are other tests for fluoride which we have not incorporated here, but otherwise hydrofluoric acid will react with the glass of the silica, because glass is silica only. You know na, glass is made of silica. Silica, SiO2. How many of you know this? Any glass is made of silica. That means silicon, SiO2. There is another confirmatory test for halogens which is known as organic layer test. Layer test, or you can say. What is layer test? Layer test. What do you do in layer test? You will take Lecine's extract and then add dilute HCl to it and then add CS2, any organic layer, or you can also add chloroform. You can take CS2, carbon disulfide, or you can take chloroform. Both you can take. And then add chlorine water and then heat. If you get orange color, it is, we can say bromine is present. If you get a violet color, you will say iodine is present. Chlorine does not give the layer test. Chlorine only gives this earlier that test of white PPT. This is the layer test. Layer test is possible only for in case of bromide and iodide. You will get this colored because we are using this aqueous layer again. Lecine's extract is aqueous in nature and we are adding an organic liquid to it. I am adding CS2 or carbon disulfide or chloroform to it, which is organic. So hence these two layers will always separate. But the color orange or violet you will observe in the organic layer only. You will get a very nice violet color in case of iodine, only if you have performed this test. But this test is really interesting. You'll get to see the exact violet color in the organic layer, and if bromine is present, you will observe a orange color in the organic layer, not in the aqueous layer. This is known as layer test. Next we have quantitative analysis or quantitative identification. That means I want to quantify that how much amount of nitrogen, carbon or oxygen or phosphorus, sulphur is present in the organic compound. You have already done the numerical based on the percentage of carbon, nitrogen present in the compound. Suppose I am saying that 68% of carbon is present in any organic compound and say 32% of oxygen. Then you will say that you will divide this percentage by the respective atomic masses and then you will divide by the simplest number, and depending on that you will get an empirical formula and then the molecular formula. This is also a way of finding the amount of various elements present in the compound. But in this case you had already know how much percentage of carbon and nitrogen was there. But suppose if I want to identify what percentage of organic compound is present, then how do I find? There are various methods. So let's take up various methods of quantitative analysis for various elements. First take for carbon and hydrogen. Suppose I am given with any organic compound. I don't know how much amount of carbon and hydrogen is present in it. So what do? I'll take that organic compound and then what do? I have to do something with the organic compound, right? To find out what amount of carbon or hydrogen is present in that organic compound. So I'll take that organic compound and I'll take excess of oxygen in presence of copper oxide. I'll burn this organic compound. So what would happen? it will form carbon dioxide and water. This would happen. If you burn any organic compound, you will get carbon and hydrogen in the form of carbon dioxide and water vapors. Suppose if I was given with this formula of any organic compound, then this would be the reaction. How can I justify this kind of reaction? You don't have to mug up this reaction, this exact reaction. Just suppose you know a burning of CH4 methane, you will start balancing this reaction CO2 plus H2O. It would be 2H2O and 2O2, right? Now the reaction is balanced. Now you can see this has the analogy with this reaction. You can simply take also, you can take C2H6 for ethane, for anything, for any general reaction having this formula CXHY, this would follow. You don't have to always memorize this reaction. No. CuO. Why we are using copper oxide? Any idea why I have introduced the copper oxide? Because copper oxide is a reducing agent. It will not let any compound to get oxidized, because if anything get oxidized, यानी उसमें it will introduce another oxygen to it from the environment, which we do not want. क्या नहीं लिखा? Second equation में no, this is the experimental condition, but the general reaction is involving this. We are using only, in the reaction we only put the reactants and the products, not the apparatus, because Cu is a part of apparatus only. We are providing the reaction medium. If you are interested, you can also, on the arrow you can write Cu if you want. So this way, KMnO4 is an oxidizing agent. Are you sure it is a reducing agent? Why we are not using another kind of reducing agent? That is the question. Why we are not using another kind of reducing agent? What kind of reducing agent we can use in this reaction? Because I have to choose only that kind of reducing agent which does not participate in this reaction, which does not hamper this reaction. If I take KMnO4 or dichromate or any other reducing agent, it would react. Why have I would taken copper oxide? Because it would provide maximum to the oxygen, and copper is a metal which will not participate in the reaction, and hence I have taken copper oxide. I can also take any other reducing agent which does not participate in the reaction. So that is the gist. So what do I do if I have burned the organic compound into carbon dioxide and water? So how do I estimate the amount of carbon and hydrogen? For that I have to make a setup. What is the role of salt bridge? No, this is not salt bridge. What is the role of salt bridge? Because we do not want the direct mixing of ions, and hence we put the salt bridge. Salt bridge, why do you connect salt bridge? Because suppose if I have copper ions and zinc ions, I have sulfate ions here also, but I do not want that the copper ions mixes it's okay if sulfate ions mixes into that, but I do not want copper ions into get mixed up with the zinc ions. For that I want the charge to be get carried by this circuit. For this, suppose if this reaction this side is full of electrons, so what happened in the salt bridge, suppose we have KCl, then these extra electrons would be carried by KCl, say like would be carried by chloride to that side, and the this is the role of salt bridge. That means transferring charge without mixing of ion. That means it would play the role of a mediator between the two half cells. This is not the salt bridge. Suppose I have this combustion tube, this is the combustion tube. I have placed the organic compound in this boat shaped apparatus, and I have started burning the compound. I am providing the pure oxygen to it. Obviously for combustion oxygen is needed. I am providing the oxygen to the organic compound for the burning of the organic compound. This mixture of gases is going through the CuO palette because I want only the reduction of compounds. When these gases pass through it, what are the gases? CO2 and H2O. So how do I measure how much amount of CO2 and H2O I have got? Because if I know the amount of carbon dioxide and water, I can estimate that I had taken, suppose I had taken X grams of organic compound give Y grams of CO2 and Z grams of water, because I already know how much amount of organic compound I have taken, and if I know the amount of the product form, I can find out the percentage of carbon or hydrogen present in it. So for this I need to quantify the amount of carbon dioxide and water vapors. So how do I weigh, how do I measure the amount of carbon dioxide and water vapors? For this I'll take this exhaust of gases, this is the exhaust of gases, यानी जो gases निकल रही हैं, carbon dioxide and water vapors. I'll put some U tube after this exhaust of gases containing the anhydrous calcium chloride. If I am taking the anhydrous calcium chloride is able to absorb water, is able to absorb moisture, and hence the exhaust which contains the water vapors, calcium chloride will absorb those water vapors into it, while the other U tube contains the KOH, yeah, that means potassium hydroxide. What does potassium hydroxide do? It reacts with the carbon dioxide to form, what is the reaction of KOH with CO2? K2CO3 and H2. So that ways I have collected the amount of water as well as the amount of carbon dioxide. So earlier I know I have taken some A gram of calcium chloride, but now the weight of the calcium chloride is A plus B, that means B is the amount of the water vapors. So I can subtract the mass of the earlier calcium chloride with the present calcium chloride. Also similarly I can see the amount of K2CO3 formed from the earlier amount of the KOH. So this way I can quantify the amount of carbon dioxide as well as water vapors, not hydrogen, water vapors. So this is the setup. Yes, you can write, but it's better if you write as, yes, you can write CaCl2 plus H2O gives CaOH twice. Why do we use lime water? Because lime, we are not testing, we are quantifying. Because मुझे ये नहीं टेस्ट करना कि कार्बन डाइऑक्साइड निकल रहा है नहीं, I want to know वो कितना निकल रहा है. ठीक है. आई एग्री कि लाइम वाटर इसीलिए होता है कि आप टेस्ट कर सकते हो, इट टर्न्स लाइम वाटर मिल्की. ठीक है, बट आई डू नो, आई वॉन्ट टू क्वान्टिफाई, मुझे जानना है अमाउंट. सो अमाउंट जानने के लिए दिस इज द बेस्ट टेक्निक, दैट इफ आई टेक एक्वस पोटेशियम हाइड्रोक्साइड एंड देन उसके बाद जो K2CO3 बनेगा, आई कैन मेजर द अमाउंट ऑफ KOH एंड K2CO3. CaOH, it would give CaCl2, 2H2O, या जितने भी वाटर ऑफ क्रिस्टलाइजेशन बनेंगे. Earlier there was a dry powder of calcium chloride, but as soon as the water vapor reaches its surface, it will form the water of crystallization. यानी अब वो wet हो जाएगा. It will get wet. So earlier अगर it was X grams, but now it is Y grams. That means the amount of water in this calcium chloride is Y minus X. Okay. Now write down one question. On complete combustion, 0.246 grams of organic compound gave 0.198 grams of carbon dioxide and 0.1014 gram of water. Determine percentage composition of carbon and hydrogen in compound. How do I do this question? I want to know the percentage composition of carbon and percentage composition of hydrogen. So how do I find it? Anybody? I know any organic compound would burn in oxygen to give carbon dioxide and water. So that means in any case 44 grams of carbon dioxide would give 12 gram of carbon. ठीक है? That means if I am burning, suppose if I left this quantity for now, if I am saying that I get 0.198 grams of carbon dioxide, that means अगर 44 gram burn gives 12 gram, that means 0.198 grams would give 12 by 44 into 0.18 grams of carbon. But I want to know the percentage in the whole compound. So how do I find, what do you do to find the percentage? You take your marks over the total marks. So if I am saying that this is the amount of carbon in the compound, that means 12 by 44 into 0.198. So what is the total amount? This is the total amount of the organic compound. So I divide by the total amount 0.246 and multiplied by 100. This is the percentage of carbon in organic compound. Simple. So similarly you can find out the percentage of hydrogen. Just solve it and tell me how much percentage you get for the carbon and as well as for hydrogen. exact percentage. What is the mass of water? 18 gram of H2O would give 2 grams of hydrogen, right? That means, so if I am getting 0.1014 gram of water, तो उससे कितना मिलेगा? 2 into 0.1014 divided by 18 gram of hydrogen. If I want to find the percentage, it would be, percentage of hydrogen would be 2 into 0.1014 over 18 into the total mass is 0.246 into 100. So tell me, what is the percentage? Anything which is not clear? Okay. You just have to divide it. Has anybody solved it? Carbon 21.9. And what about another? Hydrogen would be? It is around 4.58. But usually the total percentage is, but usually नहीं, but truly the 100%, it is 100%. So that means, what about the rest of the percentage? It must contain, it must have also contained oxygen or sulphur or any other element also. So you have not always need to make it 100%. Okay. I hope this question is clear, because rest of the method also implies this same technique to find out the percentage of any other element. Hope it is clear. Any doubts? Next we have quantitative identification of or quantitative analysis of nitrogen. Quantitative analysis of nitrogen. First is Dumas method. Dumas method. What is Dumas method? In Dumas method, you take an organic compound containing nitrogen and you heat it in the presence of copper oxide in the atmosphere of carbon dioxide. You will provide a carbon dioxide atmosphere. Again, why we are using copper oxide? Because I do not want the nitrogen to get oxidized to nitrogen dioxide. I want to keep it as nitrogen, as simple dinitrogen. Because if I do not use copper oxide, this dinitrogen will change to nitrogen dioxide. Then I'll get dinitrogen and carbon dioxide and water. So how do I quantify this nitrogen? Draw the experimental setup for Dumas method. We are providing CO2. Atmosphere. CO2, you are providing a carbon dioxide atmosphere to it. You may or you may not. quite complicated. So but the bottom line is you have to heat the organic compound in presence of copper oxide. This is the way you are providing a carbon dioxide atmosphere to it. You are passing the carbon dioxide along the various carbon dioxide pellets. These are gauges of copper oxide, so that the nitrogen does not get oxidized. You have maintained the copper oxide atmosphere throughout the heating process. So that is the bottom line, that is the gist, that you just have to heat the organic compound in presence of copper oxide, and the amount of nitrogen, dinitrogen released would be measured by the nitrometer. It measures the amount of nitrometer on the basis of the height of the mercury, level of the mercury that has changed. This is the mercury. On the basis of the amount of nitrogen, dinitrogen that goes inside this flask, the level of the mercury will rise or fall. So on that basis, using those calculations, you can find out the amount of dinitrogen released. When the mercury will fall, and usually mercury would fall when the amount of dinitrogen will fall. So what is the general reaction? Cx HyNZ plus 2x plus y by 2 CuO gives x CO2 plus y by 2 H2O plus z by 2 N2 plus 2x plus y by 2 CO. So here we get the volume of nitrogen. We get the nitrogen in the form of liquid. We would be able to measure the nitrogen in the liquid form. So how do I calculate if I have given the same kind of numerical just like we did? So how do we find out? How do I convert the volume into grams? Everybody is through with the Charles law, Boyle's law, and the combined ideal gas law, P1 V1 by T1, P2 V2 by T2. Okay, I am saying if I am taking the gas at STP, what is STP? Standard temperature and pressure. What is temperature at STP? What is temperature at STP? 298 or 273? 273 or 298? 298. What is the pressure? 760 mm of Hg, right? And this is actually 273. It is at NTP that you have 298 Kelvin. It is normal temperature and pressure. NTP and STP are different. Standard temperature and pressure are different. Okay. What is the volume at STP? 22400 centimeter cube. This is the volume. If I am saying that this is the volume, this is the pressure, volume and temperature condition at STP, and this is the pressure at which the nitrogen is being collected in the nitrometer. Okay, if I know this pressure and I know the volume also, or I know the temperature also. I know the temperature, I can measure the volume. So how do I find the volume? So do you think that the nitrogen which has been collected in the nitrometer is at the same pressure as that of atmospheric pressure? Is it necessary? it is not necessary that the nitrogen which has been collected by the nitrometer, which has been measured by the nitrometer, has the same atmospheric pressure. For this you have to suppose the nitrogen is being collected in this flask, but the total pressure, yani that means the total pressure exerted by this nitrogen would be equal to net pressure equal to atmospheric pressure minus aqueous tension. What is aqueous tension? Aqueous tension is basically the vapor pressure exerted by the liquid. That means this pressure above this liquid is known as aqueous tension. So the net pressure by the nitrogen is this atmospheric pressure minus aqueous tension. So you would be given the aqueous tension also. So write down one question. Above the liquid. When you, there is no difference between the aqueous tension. It is a more refined term in case of for the liquids. Usually vapor pressure exists for gases also, for liquids also, and for solids also. There is always some pressure above any solid, liquid or gas, but when we talk about specifically about liquids, we can call it as aqueous tension. होता है ना हमेशा कोई एक प्रेशर किसी भी चीज़ के ऊपर. This is solid, but there is some pressure above it. This is known as vapor pressure. Write down one question. In a Dumas method, for estimation of nitrogen, 0.3 grams of organic compound gave 50 ml of nitrogen collected at 300 Kelvin and 715 mm pressure. Calculate percentage composition of nitrogen in the compound. The aqueous tension is given as 15 mmHg. How will you proceed? I have given the starting amount of the organic compound and I have given the amount of nitrogen that has been produced at what pressure and the aqueous tension. So first I will apply the P1 V1 concept. That means P1 V1 by T1 is equal to P2 V2 by T2. At one side I will put the standard temperature pressure condition. And what would I put in the pressure column? 715 is the pressure at which the nitrogen has been collected. But the aqueous tension is 15 mm of Hg. That means what is the net pressure? Net pressure is equal to 715 minus 15 mm Hg. It means 700 Hg. mm of Hg. So I'll put the pressure as 700. I want to find out the volume at this pressure, right? I have given with the temperature also. So what would be the volume? Volume at STP is equal to 273 into 700 into 50, 300 into 760. I know this amount of nitrogen has been produced at this temperature and pressure. So what would be the volume if I change the temperature and pressure according to STP? ठीक है, I am taking the same amount, I am taking the same condition, but I am changing the condition of temperature and pressure. Then I am trying to find out the volume that would have existed if the temperature and pressure were according to the STP. Getting? This is how I have used P1 V1 by T1 is equal to P2 V2 by T2. All right. So what would be the volume at STP? It is around 41.9 ml or centimeter cube. If I am taking 50 ml, it should be ml, right? Standard right, standard pressure. Why? P1 V1 by T1 is equal to P2 V2 by T2. Suppose I am saying this is for STP. So that means if this was 700, right? This is the pressure I have taken from this. Volume is 50 over temperature is 300, right? Temperature would go this, it would be 273 and the pressure would go down. Yes, you are calculating the amount that would have existed if the temperature and pressure were according to the STP, right? कि अगर यही कंडीशन STP पर आप देते तो क्या वॉल्यूम होता? ठीक है? Why we are doing this? Because we want to compare. Just like we have compared 44 gram of carbon dioxide is giving away 12 gram of carbon, because we know कि carbon is always carbon will always form carbon dioxide in 1:1 mole ratio. So simple analogy is there. So this is the volume at STP. So I know that for STP the volume is 400 centimeter cube, or I can also write 400 milliliter also. Okay, this is the same units. We can write centimeter cube or milliliter. We know 400 milliliter of nitrogen has the mass of 28 grams. Okay, dinitrogen STP पर कितना वॉल्यूम होता है स्टैंडर्ड टेम्परेचर? 28 grams. So if I have the volume of 41.9 ml, what would be the mass of nitrogen? Exactly 28 upon 22400 into 41.9 grams of nitrogen. So this way I have obtained the mass of nitrogen. So if somebody asks me to find out the percentage of nitrogen, then I'll simply take this amount divided by the total organic compound amount into 100. Is this clear? Because this is a very important numerical. No, this is the case when we were given the volume instead of the mass. Usually the process remains the same, the procedure remains the same, that if I am saying 44 grams give 12 grams of carbon, 18 grams of water, 2 grams of hydrogen. No, why you are using STP? Because STP will give me the will be able to relate the standard mass. What is the atomic mass of nitrogen, dinitrogen? 28 gram. I know what is the relationship between mass and volume. I know 28 grams is the mass of the dinitrogen at the STP volume. What is the STP volume? 22,400 milliliter. So I know the volume of my compound. I know the volume of my compound, so I want to convert the volume into mass. So that's why I have compared. First of all, I have to make sure that the condition of the STP are as same as of temperature and pressure. यानी मुझे temperature और pressure की condition भी same करनी पड़ेगी अगर मुझे उसे compare करना है, क्योंकि यहाँ पर दोनों these are different. First I'll make sure कि ये condition भी मैं same करूँ, तब I'll find out the amount कि कितना आना चाहिए. Getting? Let me again explain this. Suppose I have given amount of nitrogen produced at this temperature and pressure, but I want the mass of nitrogen. So I have to convert some factor of volume into the mass, right? But I know a standard condition, I know a standard parameter that the 28 grams of nitrogen or any molecule exists has this volume at standard temperature and pressure condition. Suppose if I am talking about oxygen, oxygen has the molecular mass of 32. So 32 grams of oxygen at 273 Kelvin and 760 mmHg will have the volume of 22,400 ml. ठीक है, so this way I can relate mass by volume, but the condition was the pressure and temperature should be 760 and 273. So here if I want to convert the volume into the mass, first I have to change the pressure and volume condition into the standard condition and then find out कि अगर अभी ये pressure और temperature है तब ये volume है, लेकिन अगर ये वाला temperature और pressure STP के according होता तब क्या volume होता. ठीक है, उसके बाद जब ये volume आ जाएगा then you will convert it into mass and then I can easily find out the percentage. Understood? So what is the percentage of nitrogen? At least tell me. What is the percentage of nitrogen in this? How will you find the percentage? You will take this mass as such. Suppose this is m over total mass is 0.3 into 100 into 100. (17.4) right, 17.4 percentage. Done? There's another method to estimate the amount of nitrogen. It is known as Geldahl method. Has everybody seen the Geldahl flask in the lab? It is somehow, it looks like a round bottom flask but an elongated round bottom flask. This is known as Geldahl flask. It is mainly used for heating purposes. Okay. So in this method you will take some organic compound heat it in the presence of concentrated H2SO4. If I am saying this the organic compound contains nitrogen, because I am estimating nitrogen, right? Then the compound would form ammonium sulfate. Then I'll heat this with NaOH, and this would release ammonia gas, and this I'll estimate the amount of ammonia gas release would give the amount of nitrogen. But how do I estimate the amount of ammonia? I'll pass this ammonia gas over the concentrated H2SO4 of known concentration, known molarity or normality. ठीक है? Just suppose I have 100 rupees. I am left with 30 rupees. That means I have given 70 rupees to somebody. This is the way. Suppose I don't know what amount of ammonia has been liberated, but suppose I am saying that I am passing this ammonia gas over the known amount of H2SO4 having known concentration, and what is the amount of concentrated H2SO4 remaining. Then I can find out what is the amount of concentrated H2SO4 used by ammonia to neutralize to each other. Ammonia is a base and H2SO4 is an acid, and hence they will react, and the remaining H2SO4 I will back titrate. Okay, I'll estimate using NaOH. So basically this is a bit complicated. We are using two titrations here. So first I'll titrate the remaining H2SO4 with the NaOH. Suppose I had taken x ml of H2SO4 and y ml of NaOH was used. So that means x में से y वॉल्यूम चला गया होगा. ठीक है, तो यानी कितना मेरे पास बचा z ml. तो z ml इतना ही होगा, इसका मतलब जितना कि अमोनिया है. यानी z ml किसने ले लिया होगा? अमोनिया ने. ठीक है, इफ x was the total amount और उसमें से y ml NaOH ने यूज़ कर लिया, दैट मीन्स जो बचा हुआ अमाउंट है किसने यूज़ किया है? अमोनिया ने, टू न्यूट्रलाइज. ठीक है, so this way I can find out the amount of ammonia and hence amount of nitrogen. ठीक है, so nitrogen में what is the molar mass of NH3? 14, 17. So that means 17 grams of ammonia would give 14 grams of nitrogen. On the similar lines हम ये कर सकते हैं. ठीक है, but the experimental setup was bit different. Next method is quantitative analysis of halogen. For this you will take an organic compound, heat it in the presence of fuming nitric acid in a Carious tube. Carious tube क्या होता है? It is a sealed tube. ठीक है, you will take your organic compound in a small tube. This is your organic compound. ठीक है, you will provide the fuming nitric acid. Fuming nitric acid. ठीक है, this is your organic compound in the tube and you are providing the fuming nitric acid to it. These are fumes and this is your organic compound. The fumes will travel through the tube, and this is on the outside of the tube you have AgNO3, right? And this is how you start heating it. This is a sealed because we do not want the halogen to escape or any other gas to escape. Sealed, बंद होती है. Usually you seal the have you sealed the capillary tube in your school? You just heat it and just roll it.
Yes.
This way you can seal it. So this if this is the reaction, this is the organic compound and you are heating it with the nitric acid, then what would form? क्या बनेगा? Suppose it has halogen in it and you are reacting it with HNO3, then what would form? HX plus ANO3. And what if I add AgNO3 to it? It would form AgX and HNO3. So basically this is sort of halogen test जो आप लोगों ने किया था अभी. उसमें आपने AgNO3 डाला था ना?
Yes, ma'am.
To form the precipitate. The amount of precipitate will give the amount of the halogen present. Now write down one question. In Carius tube of estimation of halogen, .15 grams of organic compound gave 0.12 grams of AgBr. Find the percentage of bromine in the compound. This is simple, right? Because I know that the Ag, suppose if I am getting AgBr, it would be formed by only 1 mole of bromine. That means what is the molar mass of AgBr? Silver bromide. It is 188. So 188 grams, 188 grams of AgBr would give, what is the molar mass of bromine? 79.9, but usually we write as 80 grams. It is 79.9. Okay. So if I am saying that 188 grams of AgBr is giving away 80 grams of bromine, then 0.12 grams of AgBr would give 80 by 188 into 0.12 grams of bromine. And if I want to find out the percentage of bromine, then the same amount divided by the total mass, that is 0.15 into 100. Understood?
Yes, ma'am.
All of you.
Yes, ma'am.
यहाँ से आवाज़ नहीं आ रही? पक्का? Tell me the percentage of halogen. जी तो डालो 188 यहाँ पर, समझ आ रहा है ना?
Yes, ma'am. हम सेटअप कैसे करेंगे इक्वेशंस के रिएक्शंस को, जैसे AgBr BR, हमें कैसे पता चलेगा कि BR है मतलब CO2 की रिएक्शंस कैसे हम, अगर हमें ये नहीं, आपने नहीं सिखाया तो हम अपने आप कैसे करें
कि रिएक्शंस हो रही हैं,
कैसे हो रही है, मतलब कैसे तोड़े, कैसे बनाए, कैसे
प्रोबेबल प्रोडक्ट्स आपको हमेशा बताऊंगी कि अगर आपको पता है वाइट प्रेसिपिटेट बन रहा है तो आप क्या करोगे कि इट इज़ AgCl which precipitated out, not AgNO3 because it is soluble. So that phase. What is the answer? 34.04, right. We can similarly identify sulfur. On the similar lines, we have the numerical for sulfur, but the procedure is we heat the organic compound in presence of fuming nitric acid, but we will precipitate out sulfate. Sulfur is maybe present as sulfate, so we will add barium chloride to it so that the sulfur would precipitate out as barium sulfate. Barium chloride is soluble, but barium sulfate is a precipitate. So adding barium chloride to it, to the mixture, would precipitate out sulfate. So estimating the amount of barium sulfate, I can find out the amount of sulfur. So if I am saying what is the molar mass of barium sulfate, it is 233. So 233 grams of barium sulfate would give 32 grams of sulfur, right? Because what is the mole ratio? For 1 mole of barium sulfate, you will get 1 mole of sulfur is combining. ठीक है? So similarly, you can proceed the same numerical for sulfur also. Only this step has been changed. In halogen, you added silver nitrate, but in this step, you added barium chloride. Next, we have estimation of phosphorus. For this, you will take organic compound, heat it with fuming nitric acid, and the phosphorus would get oxidized as ammonium phosphomolybdate. You will take the organic compound, heat it using fuming nitric acid. By adding fuming nitric acid, you will heat it. Then you will add ammonia to it and then ammonium molybdate. This is the test you must have performed in school. This gives a very nice yellow PPT of ammonium phosphomolybdate. Ammonium phosphomolybdate. So what is the molar mass of ammonium phosphomolybdate? It is 1877. 1877 gram of ammonium phosphomolybdate gives just one. There's only 1 mole of phosphorus in it. What is the molar mass of? What is the atomic mass of phosphorus? 31. 31. So 1877 gram of ammonium phosphomolybdate gives 31 grams of phosphorus, right? So if I am given any amount of ammonium phosphomolybdate, I can find out the amount of phosphorus and hence the percentage of phosphorus. But this is the way. You will add ammonia and ammonium molybdate. Next we have estimation of oxygen. How do we estimate oxygen? We will take the organic compound and heat it in the stream of nitrogen gas and pass the reaction mixture, जो भी exhaust होगा, the exhaust of gases is passed over red hot coke. What is red hot coke? High temperature coal. Red means it is at very high temperature. Red hot coke passes the exhaust of gases over the red hot coke. Obviously, when you are burning the organic compound in presence of nitrogen, dinitrogen, then the oxygen would form, and this mixture of gases, oxygen and nitrogen, we are passing this mixture of gases over red hot coke, which would form carbon monoxide. यही बनेगा ना. कोक के अंदर क्या होता है, कोल के अंदर कार्बन, राइट? सो कोक विड फॉर्म when all the oxygen is converted into carbon monoxide, we will pass it to it over I2O5, which is iodine pentoxide. When the exhaust of gases is passed over red hot coke, carbon monoxide will form. We will pass this carbon monoxide that has been formed over the iodine pentoxide, which would form iodine and carbon dioxide. So, by estimating the amount of iodine, I can find out the amount of oxygen. How do you estimate iodine? You want to estimate carbon dioxide, but carbon dioxide is in combined form. You can also do that. You can also estimate carbon dioxide and then estimate carbon separately and then oxygen, but you can also estimate using iodine also. This is also correct way. So again, the numerical is on the similar lines. You can find out the value of carbon dioxide and amount of carbon dioxide formed from the oxygen. I am saying 44 grams of carbon dioxide would produce how much amount of oxygen? 32. It is present as O2, not O. When the phosphorus was present as P only, we have taken 31, not 62. We will take the atomic mass in terms of the number of atoms present in the molecule. If it was present as H2O, we will take as 2 grams, not as 1 gram, because for hydrogen atomic mass is 1, right? Next we have determination of molecular mass. Till now we have done the various purification techniques, qualitative identification and quantitative identification. But now I want to know the molar mass, molecular mass. Suppose I have given a compound, I don't know how much amount of the complex that has been formed. Now if I want to find the molecular mass of any compound, I can find out using two techniques. There are various techniques. There are Victor-Meyer methods. Victor-Meyer method. Another is silver salt method. Another is chloroplatinate salt method. For now we will discuss only these two methods. Silver salt method is used to estimate the amount of the acid, organic acid, while the chloroplatinate salt method is used to estimate the amount of or the molecular mass of the organic base. What do we do in silver salt method? We'll take any organic acid and treat it with the ammonia or ammonium hydroxide. Ammonia in the more dilute form exists as ammonium hydroxide, right? Then it would form a ammonium salt. If I treat it with AgNO3 silver nitrate, it would form a silver salt. The acid, the organic acid has formed the silver salt of the acid, right? And if I ignite this silver salt, if I burn this silver salt, I will obtain the metallic silver. So if I take some amount of, I know the amount of organic acid I have initially taken, and if I know the amount of the metal I have got after this whole procedure, after the whole process, if I know the amount of the metal that I have obtained, then can I find out the molecular mass of the silver salt? Can I? How? Because I know that if I am saying, if I am taking the, what is the molar mass of silver? 108. And suppose what is the molar mass of RCOAHG? Suppose I am taking any acid. What would be the molar mass of RCOOAG? It would be equal to RCOOH, right? It would be the molecular mass of RCOH minus H and plus Ag. It would be the case. Minus H. H हटाओगे, Ag ऐड करोगे तभी आएगा, ठीक है. If I know the molar mass, suppose if I know this molar mass, if I already know this molar mass of the salt that has been formed, I can find out the molar mass of this acid or vice versa. So that means if RCOOH is equal to RCOOAG minus Ag plus H, यही हुआ ना, ठीक है. That means if M amount of organic compound gives M1 amount of RCOOAG to give M2 amount of Ag, right? So if M1 amount of this salt is giving M2 amount of the silver, what would be the amount given by 108 grams of Ag? I am saying that M1 amount of RCO, silver salt of organic acid, is giving away M2 grams of silver. or I can write m2 gram of silver is obtained from m1 gram of RCOAg, silver salt of organic acid. Then what would be the mass if 108 gram of silver has been produced? What would be the mass of the silver salt of the organic acid? It would be m1 by m2 into 108. This is how I obtain the molecular mass of the salt, of the silver salt. So using this formula, I know the molar mass of Ag. I know the atomic mass of Ag, it is 108. I know the atomic mass of hydrogen, and now I know the atomic mass of silver salt. M2 as 108 because I am interested in knowing the mass of the unknown silver salt. I know that suppose I know that y amount of metal is produced by x amount. So I am saying if y amount has been produced by x amount, then what would be, I know the standard condition. I know that 1 mole of compound gives 1 mole. So if I know 108 grams of silver would be given by standard amount of the salt. So that way, using that analogy, using the simple mole concept, I am finding out the molar mass of the silver salt. Just like we did in the earlier case, in the case of nitrogen, carbon, oxygen. This is the general analogy. If this much grams is produced by this much amount of salt, then what if the amount was 108 amount of silver, then what would be the molar mass of the silver salt? If I know the molar mass of the silver salt, I can find out the molar mass of my organic acid. So hence we can find out the molar mass of the organic acid using silver salt method. Why silver salt method? Because we are producing the silver salt of the organic acid by using silver nitrate. Understood? So rest we will continue in the next class. We are left with the chloroplatinate salt method and the mass spectroscopy, and rest we will also do some numericals. Okay, any doubts till now?